break. So at DConnect, we're really a digital health innovation hub. So very much focused on helping companies that are anywhere in and around the digital health space. Those are companies that are serving maybe the healthcare system or providing to larger healthcare entities, companies, FDI companies, but have a product and or service that will have a digital element to it at the moment or will in the future. So really about enabling. We have our main funding from Enterprise Ireland, and we are building out an innovation centre. So we are sitting at Dundalk IT. There is a regional development centre there, but we have received a substantial amount of money to build out and focus on connected health and wellbeing, which is, you know, a big part of the competency at Dundalk. We've several groups who have been developing digital technologies for senior care, regulated software for large companies. And there's quite a lot of capability already there. We're building on that. We've had sponsorship from local and national, and also various different companies that are also very much placed in this space. So there's a lot more going on maybe than people would realize in the area, I suppose at a local level, but as I've just come off a call with the IDA at a very much a national level, from early stage company to SME, right the way through to the large corporates. Digital health and, you know, technology is a big focus for them. So we're really about fostering and enhancing any innovation that we can to, I suppose, fly the Irish flag and show how capable we are here. So this is bringing people together from all across those sort of sectors to address any of the societal and healthcare needs that we see. And, you know, the shift is there from, you know, healthcare at a clinic, at a hospital facility, to healthcare at home. And there is a lot of really good initiatives that have been rolled out in other parts of the world, but also in Ireland. And actually, yesterday, speaking with a group at the Drogheda Lady of Lourdes Hospital, they really reduced the waiting list for their orthopedic surgery and follow-up, you know, dramatically during COVID, and found a much better way of doing it by doing a kind of a triage at a distance, so a telehealth sort of mechanism, and enabled by a technology. So we're going to see more and more of that, and it's right on your doorstep, and it's happening all over the world. So it's really for us, allowing and building a bridge. We are able, I suppose, to connect people. We have our cluster that we sit with, the Connected Health and Wellbeing Cluster at Dundalk, and there's an awful lot of people within our network. So we can connect people, we can connect the businesses. We actually have good relationships into the healthcare sector, across into our own college and other third level institutes. And it's really then about supporting early stage companies. It's about commercializing research, if it's something that looks like it could be leading to a spin out company. And then to provide these larger businesses and investors, as we talked about just a little bit earlier with Iain, who are seeking to do something in the space and do something different. And they are evolving as well in what they provide by looking at internally their own capability, but also looking externally and seeing, is there something new they need to pay attention to, and ultimately really maybe purchase. So we have a broad audience, you know, the early stage companies, and we're looking at an entrepreneurial program at the moment. There is a New Frontiers program at Dundalk already, and that covers any and all types of businesses, but we'll focus ours more on the digital health space. And then, of course, anything that goes into early stage companies has to be supported by some sort of capital and investment, and we've good relationships across some of the investment sector. So keeping those people informed, connecting them with each other is really important. Then again, the larger companies, the SMEs and the corporates, a lot of great SMEs in the sector who are so busy that they barely have time to maybe attend a workshop or really to keep an eye out on what's going on. But if we can enable them as well, if they transition maybe from a more traditional product to something more digital, we can find expertise and provide assistance to them to do that, or link them in with others who are doing this type of thing. We have support from government, quite strong support in terms of funding from Enterprise Ireland, but also linked in with the HSE and with others, and I'm just off a call with the IDA, and we work a bit with IBEC as well. And then of course really the talent and some of the initiative that is burgeoning and coming out of the university sector fills all of these spaces, and all of the people that are moving out of there are going into these places. So even my colleagues are looking at some of that now at the moment in terms of matching some of the needs that we see out here among these groups with some of the talent in the university. So what are our key strategies is to build a network. And I think Sarah, our colleagues on the line, she would have been looking at this slide, and we were saying we will build it, but we certainly now, probably in about 9 to 10 months on, have a very strong network. We have people on our CRM and in our network that are from all of those different sectors, and it's really important because we can hook them up and we can enable conversations and even just share the knowledge. So the knowledge that we have now is quite valuable for people that are part of our network. Sometimes people are too busy to look up, and whether you're an early stage company or maybe an SME, you tend to need to get things done. But just even kind of taking a landscape view and understanding broadly, even globally and then European wide, what's going on is important to people in the network as well. Our mandate, Enterprise Ireland funded, means that there is a large focus on creating jobs and creating businesses. And so we've been doing that probably by education, through workshops and outreach, but also just supporting early stage companies. And we offer some services, both technical and business, to enable that. We've run a lot of workshop and educational sessions focused on digital transformation, where people have to change their systems. They're moving from paper-based to digital, or their product is becoming more digitalized. So there's a lot of I suppose people now that we've engaged who can help and support others who are going through this pathway. And really we're globally focused. My background is corporate and global, and there's no reason for anybody, any part of this island, to be just looking locally, and it's wide open right now. So some of the services, and there's probably more, I just had to put something down here, is really the business strategy. Everything from doing market research studies and user studies to helping you map business model, your path to market, product launch, or if you're getting ready for investor conversations, we can help with any of that. As I said, if we don't have in-house capability, we have access in that network to an awful lot of people who do have different skill sets and backgrounds in technology, clinical and clinical access. Regulatory would be a strong one out of the Dundalk College itself, and to other industries and people who may be a customer or a potential customer in the future. Really, really important, particularly at an early stage, that you engage and know their needs as you progress. And then from a technology perspective, this is a strength in terms of being able to provide tech guidance. We've run a number of different projects over the last while looking at technology for different companies. And we're also doing prototyping as well. So, it could be researching options and guiding people, or it could be actually mocking up something that enables someone to go out and talk to their customers or to test some of their theories. And then we can go deeper and we can actually start to build out if that's a requirement as well. So we have that in-house sort of front end and back end, and really go into user testing and training if that's a later stage and we get to that point with the company. This is the team, wonderful team, really great and an energetic group. So myself, and then Sarah, who's our community and education manager, Sir Fell, who works on most of the prototyping and technology, and also Connor, who will be liaising with the external groups and also has some technical background and competencies. So any and all of us are more than happy to have a chat with you at any stage. If you have a need, we will do our best to help fulfill that need. And of course, we're running this workshop. We have another one in a few weeks, and that one is it's really something that we saw out there, where people are building apps for healthcare. They're building apps because, you know, they want to have something additional to share with their potential customers, or they need to track data, or they want a data play, which is going to be part of their sort of business future strategy. And so this one is on the 8th of December. Keep an eye out for that. Feel free to contact us, pop onto the website. There's a contact form there. Otherwise, maybe most of you have my email. I will be, I suppose, passing over to Conor and Sarah for a little while. But do email us at this DConnect@dkit.ie, and we get back to you at some stage to try and see if we can help you guys out. And I will stop the share and come back and allow you on there, Iain. Did that work? Are you able to share now?
Yeah, I think I can share now. Yeah, so can you just see a slide now, is it?
We do indeed, yeah.
Just, okay.
Thank you. I'll put it off my...
Okay, thanks very much. Good morning, everyone. My name is Iain Keaney. I'm an AI engineer and strategist with Skellig.ai. So what we do is we help companies and organizations adapt AI technologies into their businesses. So what I'm going to be delivering here today in this workshop is part of a program that we've been doing, delivering with Enterprise Ireland as part of their digitalization voucher scheme. It's a workshop that's really designed to take organizations essentially from the point of not really knowing anything. They may have they know of data science and artificial intelligence, but they may not have any expertise or any background in it or any experience dealing with it, except from just being bombarded with lots of hype around the field from social media and a lot of there's a lot of businesses out there who are just propagating a lot of false information for the purpose of marketing on it. So this workshop was really designed to show you basically where the real applications are today, and how it's really delivering value to organizations. So it's a program that was when it was originally designed, it was 2 days long, and we have essentially about 2 hours to do it, but which is going to be fun. But so what we do as an organization, we deliver a lot of training both on the strategy and the technical side for different companies. A lot of our work is linked in with Enterprise Ireland. So Enterprise Ireland can basically fund things like the digitalization voucher scheme, can help you as a company develop your data strategy for the future. We do have a new resource becoming available next year, around February, where it'll essentially be prototypes and business studies of AI in AI applications actually used in real business. Those prototypes will be free for anyone to actually access, download. You'll get the source code for it'll be completely open, and you can implement it into your own organization. So if you're interested in hearing about that and finding out more about it when it comes up, just feel free to reach out to me either by email or LinkedIn. We'll be posting more and more information about that in the new year. So thanks very much to Angela and everyone at DConnect for having us here today. This isn't. There we go. So what I'm going to be talking today about is basically just introducing what artificial intelligence is and what it means for business. Overcoming the typical barriers that we find organizations hit when they're trying to adopt AI, because we've had some very interesting conversations around with businesses as to why they're struggling to adopt the technology, identifying where the real business value is, and we're going to look at some case studies as well of artificial intelligence in being used in business. And so just to get a pulse of, or just to basically take the pulse of the room, if I can just pull up the chat, I just want to get a feel for where people are at, what they feel the sorry, hang on, I lost the link. This.
If you can just ask, I mean, it's a small enough audience, Iain, I think, and people are more than happy, I'd say, to unmute and speak if you want. Yeah.
I have it ready there now. So there's a link in your chat. If people want to just click on it, I find it like in the online presentations that people are a bit more comfortable with links like this. But yeah, if everyone can just take a minute and click on the link. Basically, what does artificial intelligence mean to you? If you can enter in a couple of words, and we will have a look at to see what the so we have opportunity and unknown potential. Not a lot more. Buzz, someone's saying buzz. That's an interesting one to now. Okay, I need to, here we go. Okay, automated decision making, tailored content, buzz, automation. Can you all see this screen now with the word cloud?
Yeah, it looks great.
Yeah. Okay. So knowledge, future proofing, automate, optimizing data, opportunity is a big one, and automation are the two big ones coming in. Black box is a really interesting phrase to use, and very relevant. Assist in making decisions, tailored data, efficiency, knowledge, faster brain, future proofing, tailored content, data driven, understanding my needs. Okay, that's an interesting insight to see what people's perspective of this is. So essentially, to look at it in its strictest form, I'm just going to switch back over here now. So you can see the main slide now, I think. Artificial intelligence is essentially just, it's an algorithm that, when given some data, can make an intelligent decision, and just one intelligent decision. And it's limited in terms of the type of decision that it can make. And it can make an intelligent decision on what that data means, which you can use to inform your next move. That's all it is. So what I mean by algorithm is, an algorithm is just a few lines of code with a bunch of numbers associated to it. It's not overly complicated as such. The data is probably the most difficult thing. Data is essentially any form that information can be saved in. So that could be an image. An image is data, or it could be an Excel spreadsheet, or it could be an audio signal from, that's what your Alexa or your Siri does, or OK Google. So anything that data is any form that data is stored in, it can take that. It does have the restriction though that the AI can only ever handle one type of data, and that data always has to be presented in the exact same way. You can have multiple AIs, but it needs to take, each one needs to take data in their own prescribed way. So the intelligent decision is really where people get confused. Basically, it can make one intelligent decision, and even at that, though, its ability to make those decisions is quite limited. It can only identify typically a small range of outputs. It doesn't handle open-ended questions that it can then have some time to think about and come up with various options that it's never thought about before. It's trained to answer one question based on the examples that I've seen before, and it's basically does this data represent option A, option B, or option C, and it gives you a confidence value for each one of those. So the AI learns how to make this decision from previous experience, and by previous experience we mean that we've shown it. So the typical form in this, some AIs are actually allowed to go and develop their own experience, but the typical form for this is that we use historical data sets to train them on, and historical data sets that have been that have a result associated with them, so we know what the actual answer is. So we can actually say, okay, this is the data, and this was the result from it. Now, when you see new data come in, try to predict what the result is going to be. So that's essentially what artificial intelligence is. So an example of this, which is very common, it was one of the very early applications of AI in industry, was predicting customer churn, particularly for utility companies. So if you consider a utility company, they will have a data set on their customers. And it'll look something like what we have here on the left. So they'll have an ID for the customer. They'll know where they live, what their address is. They'll have a rough age. They might be able to figure out your occupation. They'll know if you're living with people, if you're house sharing, or if you're living by yourself, or if you're just living with your partner, or if you've got kids who are living there as well. From your occupation, then they'll be able to figure out a rough range of what your salary should be, because they know where you're living. They'll be able to get a rough idea of what your mortgage is, or your rent is. And they'll know how much electricity you've been using in the past, or whatever service they're selling. So what your previous bills have been, and what discounts and offers that you've responded to in the past. So they can feed that into their AI algorithm, and the AI basically then suggests, is this it essentially figures out what's your price sensitivity and to the service that they're providing you, and what's your likelihood of churning in the next 12 months, or the next 6 months, or the next 3 months, or even within a month. And when they do that, then they can take action to actually go and try to keep you as a client. So an interesting example of this was my dad, about 12 months ago, my dad was thinking that he'd been with the one electricity supplier for years, and he hadn't really shopped around, and it occurred to him that he probably should just see if he can get any better deals with other suppliers. So he was meaning to, like all of us, he kind of put it a little bit on the long finger. He was meaning to get around to looking at at what the other utility companies were offering, and shortly he got a phone call from his own supplier saying, "Hi, we just want to make sure that you're happy with your service, and if there's anything we can do to make you happier," essentially. And with that, without him ever having to look up any other deals, they offered him a package for the next 12 months that was much better than what he was on. And he said, it saves me the time of going and looking up what else is available. I'll just take that. And essentially what happens there is they realized that he was a customer profile that he wasn't in a contract, because he'd been with them for 12 months, for many years, and their contracts are only 12 months. So he could leave at any time. His customer segment meant that he was flagged as a potential client that was going to churn. So a sales agent rang him up and to see if there's anything they could do to lock him in for another 12 months. And that was even, at that point, he hadn't even Googled or looked up any other suppliers. So it's not that data was, that they were buying data from some third-party provider to realize that one of their clients is looking up their competitors. It's just that based on his profile and his usage of their service, they flag them as a likely person to churn. And why that's important to companies is because the cost of customer retention is actually 5 times cheaper than acquiring new customers. So customer churn is a huge hit for companies. Also, if over this workshop, you can, if you have any questions, instead of putting them in chat, you're welcome to just jump in and ask me, because if you do have questions, it's likely somebody else is probably thinking the same thing. So you're welcome to join the conversation, and I find sometimes that's where people get the most value out of, is when we have a discussion like that.
Iain, then I'll take you up on your offer of that, and so if you don't mind. Garbage in, garbage out. So that's a fairly short list of data points, let's say, in terms of occupation, salary, and all that crap. So I would say
that was for illustrative purposes.
No, 100%, yeah. But I guess obviously the more information you have, the better. But is there kind of a considered gold standard for? I mean, you can't validate everything, right? So if I'm selling into a hospital, for example, there's only a certain amount of data I'm going to have. Most of those hospitals are going to be private enterprises. I won't be able to access their income, their expenditure. I won't know anything about the particular purchasing department necessarily. So I mean, this kind of algorithm, there must be limitations to it where simply you just don't have access to the data.
Yes, absolutely. Yeah, and you hit the nail on the head there. For smaller organizations, using this type of churn prediction can be very difficult. So I haven't seen any. I've heard stories, but I haven't seen any real application of this where you have small, where your customer base is quite small.
My customer base is potentially ginormous, but it's that customer base is behind a very thick wall. I don't have access to them necessarily.
Okay, that's interesting. Right.
So HSE, I don't know whether they publish numbers, right? But you go to the States, and the hospital groups there are run by private organizations. So we could set up a company in the morning and build a couple of hospitals and become a private enterprise trying to make a profit by treating people. But on the other side of that is a supplier into these hospitals looking to see, will this hospital churn, to use your example. It's very difficult to get information. So does that mean there are limitations to the application of AI, or are there other ways to kind of get information that will help you make decisions?
Yes to both. So to start off with, then you are very much restricted then in how you can use this. Like in this particular example, there are off-the-shelf tools that have been trained on. To make an analogy with other businesses that have smaller client bases, where they don't have so with a smaller client base, you can't actually build up a large data set either to train your AI on. So there are, like companies like Salesforce and HubSpot have built their own AI algorithms on their entire user base. So if you're I don't know if this would be particularly useful to you, but it's close to to the problem that you're dealing with for anyone who has this issue. But so what happens there is, if you take Salesforce for instance, Salesforce can have a lot of customers who all have small customer bases, but they're all very similar, which means that when you pile them all together, that's all of their small customer bases equates to a very large customer base, and they've been able to train churn predictions on that large customer base because they have access to all those engagements, and then they provide that as part of their service. So that's somewhere where the company themselves, the vendor, can't get enough data on their customer base themselves, but they can get that kind of value from the likes of Salesforce or HubSpot. Okay. Now, one issue with that is that those churn predictions don't tend to be as well, because they end up training it on customer bases that are very diverse. So the closer you can get, you can basically narrow that down to your type of customer base, the better it will work. So there is a trade-off there. You lose some accuracy, but companies our business have had a lot of success with their systems where, like, Salesforce can basically flag when a new opportunity that you'd be chasing is likely to get lost, or one that's hot and is soon going to convert into a sale, just to make you aware of how you can of the customers to pay the most attention to at that time.
I'm just thinking, Iain, of I'm coming from the science background, bit like Ronan. We would have always kind of studied a subset of population in order to be representative of a much larger population. So I guess having the best subset here is what I suppose Ronan's referring to. If you do have potentially large amounts of potential customers or people to target, can you use a subset that's representative? And there's probably others actually as well that would be asking a similar question. You have access to maybe some data, and I think you and I chatted, and this was one of the thoughts as well. I don't have access to the beautiful big data set that I'd like to train my AI and have it perfect. But can you do a simulation? So can you do a subset and have that representative, or can you use that to produce simulations? And it's probably not the right word, but so you can mimic over and over that subset and get some sort of representation. Yeah. Or is that a dangerous thing to do?
Yeah, that's the question.
Yeah, so you're actually trying to work in the reverse order. So your customer base is a small subset or a subset that you don't have a lot of data on. So either way, it's a small data set, even if the customer base is large. So then what you want to do in that case is you want to see if you can get a much larger data set to train your model on that can then be possibly be applied to your smaller data set. So then when you're doing things like that, there are actually tons of freely available data sets available that you can use for your. So this is a hot topic right now. It's called transfer learning, where you can take a much larger data set, you can train your AI model on it to do something useful, and then when that model is working quite well, you can then repurpose it and train it on your much smaller data set. The use of that of those techniques is at the moment quite limited to the types of applications. I haven't heard of it being used successfully in churn prediction. That doesn't mean to say that can't be done, but certainly possibly an area to go to look at. Then after that, you can then use those larger data sets to augment your own data set. So you might be able to say if you get a larger data set, to try and use that to increase the size of your own data set by, okay, the data that you're putting in won't strictly be true because it's coming from a different source. But if you can get a system to do working effectively on a data set that is representative to what you're actually going to be doing in the real world, then once that's kind of operating that field, and then you apply it to your own, to your own customers, and the limited data that you have there, you can then start to test that in that area and start to get some results from that and improve it as it goes along then after that. Does that help, Ron?
Yeah, no, it's perfect. Yeah, I mean, look at just trying to get my head around this in some ways, but
yeah,
in other ways, AI is data, and data is big data, and it's just what you do with it. Like it's taking your big lumps of Excel sheets and doing something with it. So, yeah, no, that's great. Thanks a million for that.
Okay, no worries. It is when in the situation that you described, where you are. Where you do hit those walls effectively, blocking you from accessing, from seeing that data, it does become much more difficult. And so there, in certain areas, there has been workarounds like using other data sets to augment your data, or repurposing other models, but that still remains a bit of a trial and error process, and won't be so not to oversell the concept of customer churn. Basically, it won't be a straight path, and you will be flying in the dark there to some degree.
Love it. Yeah. Okay. Thanks for that again.
No worries. So one of the something I get quite a bit is Angela, we even touched on this before the call, was like we all knew AI being around for a very long time, but it's only in the last number of years that's actually had implications in the real world, at least ones that we know about. It's actually been surrounding us since the mid-90s, but we've only been really aware of the huge applications of it in the last 9 years, since 2012. So and there's a reason for that. There's a reason why it has such a sketchy past, and why there's essentially an AI boom right now. So AI came. People refer to the origins of AI from a 1950s a paper that Alan Turing wrote in the 1950s, or sorry, in actually 1950, where he defined the Turing test, which is basically a test to see if machine is actually intelligent. But the reality is that even his work previous to that would qualify today as artificial intelligence in the truest definition of the term. Then in 1956, the term AI was coined by a research. Well, it was coined in a research proposal for a summer workshop, and it's been so a lot of people. There's a number of researchers involved in that, but the credit has been given to a guy called John McCarthy, whose father or grandfather, I can't remember which, was actually from Kerry. So with that, then AI started to get a lot more focus from an academic perspective. And in 1959, Arthur Samuel built the first AI that could play drafts or checkers. And the funny thing about that was Arthur Samuel he was actually a very bad checkers player himself. So it wasn't difficult to build an AI to beat him. So what he did was he built two and had them play against each other and learn from each other. And then ultimately built an AI checkers player better than any human. So that was in 1956. Then in the 60s and the 70s, we entered the first AI winter, where really that was like, aside from a nice party trick, there was no real applications for AI. And that came with the US government commissioned an investigation or a report on the applications of it. I think it was called the Hill Report or something, that came back and said, you know, it's an interesting technology, but there's no applications to it. So then in 1978, we had the first expert systems. So expert systems were based on what's called symbolic programming. It was AI for the first up until the mid 90s. It was the main type of AI that was being explored, and it's kind of similar to what we use today as decision trees. So expert systems were delivering a lot of value back in the late 70s and early 80s for very large corporations, and because of that, they got the whole industry got a huge amount of investment into it. Everyone wanted to be part of it, but it very quickly realized that these systems they cost a lot of money to maintain, and they needed a lot of data and a lot of processing power, and the value that they were giving for most organizations was actually very small, if any at all. So with that, then in the late 80s, the bubble burst in the AI industry, and we entered the second AI winter. And so after that, AI kind of became a dirty term. Investors or corporations didn't like talking about it. They didn't like talking to people who did talk about it, because they felt that, okay, well, that means you're just a crazy person. But then in the mid 90s, and this purely from academic perspective, and it was really the academic pursuit of this that kept the technology alive. So in 97, IBM, and they were doing this just purely from experimental point of view, they built the first chess program that bet the world master. And then 98, the first AI, it was called LeNet-5, to get a really good accuracy on recognizing handwriting was built, and it was able to get an accuracy of 99.2%. Compare that to humans, humans are for handwriting are about 92 to 94% accuracy. So it was the first AI that was able to actually outperform humans on recognizing handwriting. And that's when some of the industry started to look at AI as being, hang on, something interesting kind of going on here. Sorry, I'm going the wrong way. And then, so in 2006, so in the late 90s, people started realizing, okay, something interesting can be done here, but there was 3 stumbling blocks. Access to computation power, the access to large data sets, and the architecture of artificial intelligence hadn't matured yet. So the first one of those problems was solved in 2006 when cloud computing became more readily available, with Amazon launching AWS. Then in 2009, Google, of course, probably the only company that could really do this, launched the largest data set that had existed at the time, and still the largest data set that exists, ImageNet. So ImageNet is a data set of 4 million images, all labeled. And in 2010, they launched a competition called ImageNet competition for academics and to basically, and companies as well, but it's mostly academics that entered it, to build image recognition systems to try and test how well they perform against ImageNet. Then in 2012, a system called AlexNet was built. AlexNet was the first deep learning program that was entered into the ImageNet competition. So deep learning is essentially, it's the AI that we all tend to talk about today. It's what Netflix uses on the recommendation systems. It's running on your phones when you're doing predictive text. It's running on your cameras when it's recognizing your face. It's doing churn prediction. It's doing drug discovery. So deep learning is the hot area at the moment in artificial intelligence. So Lead 5 that recognized the handwriting earlier was the first really deep learning program that was ever useful for anything. And in 2012, when AlexNet was deployed in this competition, it was the first deep learning AI that was used in this competition, and that's when people realized, hang on a second, maybe there is something to this deep learning thing. The problem with deep learning compared to all of the other solutions is the amount of data that deep learning needs is astronomically greater than any other system needed. Every other system could be used on much smaller data sets, but they require a lot more manual work to get working. And as a result of that, they don't tend to be very robust. While deep learning finally offered a path forward that provided robustness for AI, the problem is it needed data and needed a huge amount of computation power. So with those 3 things now in place, we had the conditions that were ready for the AI boom that we're currently experiencing. And then very quickly after that, so we went from like 50 years, or in fact 60 years, of going from like barely being able to read, going from playing checkers to barely being able to read handwriting. And then all of a sudden we have autonomous driving. We have AlphaGo, which is the AI that bet the world champion in playing Go, which is a far more difficult game to play than chess, especially for an AI. Then we had drug discovery in 2018, conversational AI in 2020. Conversational AI started to become feasible and more convincing. It no longer felt like you were talking to essentially a spreadsheet of possible replies, which is what chatbots were before that. And then late 2020, we had the protein folding, DeepMind's AlphaFold, which was the first time that they were able to actually predict protein folding. So the last 9 years, we've had a huge acceleration in the industry compared to the 60 years before that, where things were almost felt very stagnant. So where AI has added value in industry today is the typical applications I mentioned first. And like the area that has gotten the greatest attention has been in sales. So essentially using sales to increase your revenue. Basically, that could be through increasing your customer lifetime value or reducing your customer acquisition costs. So increasing customer lifetime value, that's using things like recommender systems to upsell to them, or reducing churn to improve your customer retention, and also price optimization as well. Depending on your industry. In the food industry, price optimization is critical for remaining profitable and remaining healthy margins, because with perishable goods like food, it becomes harder and harder to sell them, obviously. So retail supermarkets and that are now using price optimization to recognize what's the right markdown for bananas that are slightly brown, or things that are going to go out of date in the next 2 days, to basically shift them. That's not just important for their bottom line, but it also helps makes the entire industry more sustainable, and that will ultimately create less waste and have a positive effect on our situation with climate change. So then after sales, automation has gotten a lot of focus. So we've done a good bit of work now with automating paperwork for different applications. One thing that we've published is we've built a system that will read the text from UK custom forms, and it can do that with ultimately 99.9% accuracy. I think the only place it lost accuracy was because it predicted extra white spaces. So you can basically automate a lot of your data input tasks there. So where that's useful is so obviously I mentioned dealing with customs paperwork. It's used a lot for invoice processing, receipts, in agriculture and food production. You often have people going around with clipboards, recording data manually, and you have a large stack of these records that have built up over the last 10 or 20 years, and you want to basically digitize all of that. In healthcare, if you're a lot of trials are clinical trials, the paperwork is still essentially paperwork. There's a lot of there's a lot of people filling out physical forms. So rather than having a more digitalized and centralized system, so there's this is an application that can really automate a lot of that process and reduce a lot of the administration overheads on that. Also particularly in manufacturing, doing predictive maintenance, if you got any type of machines where downtime can actually hinder your profitability or the ability for your clients to use those machines. So in manufacturing, for instance, if if a production line goes down, it on average it goes down for about 4 hours. And again, on average, when a production line is down, it costs 250,000 euros of loss of production, right? So the average production line is producing 250,000 euros for it per hour, and they typically, that breakdown on average lasts for 4 hours. So that's €1 million of lost production right there. And another, then the other area that is getting more focus is in reducing waste. So that could be in demand forecasting, has gotten a lot of interest since 2016, 2017, where there were some breakthroughs made on that. That was actually done by in a data science competition. There's a platform called Kaggle that has essentially lots of free data sets available. So Ronan, you were asking earlier about how do you handle the problem of having a small data set? Well, you might be able to augment it with other data sets. So Kaggle is a website it's a data science community website, and it has tons and tons of data sets. So there's essentially two places you can get data sets. One of those is Kaggle, and the other one is basically anywhere else on the web. Just to emphasize how big a resource Kaggle is. There is also, like, Google has, if you look up Google dataset search, it's a Google search engine dedicated to just finding data sets. So that can also be useful. And these are data sets that are freely available to use. And they're free for numerous reasons. So Kaggle it's a competition-based thing. And to give you an example of the demand forecasting, that was started by a company called Rossmann Pharmacies. It was a chain of pharmacies in Germany. They actually have 3,000 pharmacies across Europe, but they're a German company. And they had a problem of predicting what demand to prepare each pharmacy for. So each pharmacy would have to predict what they were going to sell for the next 6 weeks in advance, and then order those drugs and have them in there. And if they miscalculated, then they were either had excess store, or they were losing sales to their competitors. So a new technique was developed by one of the competition entries into this for this Kaggle data set. They came third place in the competition only because the first 2 places actually cheated. But they got third place, but what they actually created was a whole new area of research in machine learning called entity embeddings that has really taken off in other areas as well. And it's one of the main drivers behind what companies are now using for drug discovery. Any questions?
I've seen this used with a company who were looking at this for restaurants. So the same thing, very much perishables, if you like. So they had to be very much predicting what their footfall would be. And some of the parameters they would put in is weather, events in the locale, just the time of the year and stuff like that. So there are things that if you sit, and it's probably quite specific to your own business. And so it's looking at that and being more specific. Maybe there is a general, back to the training of the AI with the large data sets, and maybe there are some accessible ones. So that would be interesting. I think maybe even for the participants to have some of that in the summary or from the slides later on, so that they could look at that. But then to think about their own business and the specific parameters that you would need to have in an AI system, because it will vary.
Yeah. So like in that particular example, the things that they looked at, they didn't just look at historical sales, because that only gives you seasonality in that it doesn't predict what's going to happen, like how trends are going to shift. They also looked at where are the stores located in relation to schools, office blocks, residential areas, what the weather was, what national holidays were, what local events were going on, and how far the store was away from competing stores. So that all factored into it as well. Ronan, when you were talking, I think you mentioned, or at least you seemed you were a little bit annoyed with some of the hype that can come with AI, and someone mentioned that in the word cloud as well, when they used the word buzz. So there's a lot of hype and a lot of buzz and a lot of inflated truths around artificial intelligence and what it can do and what it can't do. And I've had people argue with me that it can do all these magical things, like it can replace doctors and that, and essentially AI can't do anything that's complicated. It can do two types of things. It can automate very simple repetitive tasks, or it can create insight in identifying patterns that humans wouldn't typically be able to see. So now, when I say it can create insight and identify patterns that humans wouldn't typically be able to see, it can't say why. It can't tell you why, and it can't diagnose what these patterns are or what each group in these in this data set that it's grouped off into different areas represent. It can just say, I think there's something similar with these groups, or within this group, it might be something worth looking at. And that's all it does. It doesn't tell you anything about why. AI isn't explainable. There are some very limited systems that can provide a degree of explainability, but in general, production-based AI is generally too complicated to be able to infer why it's making the decision it's making. But even with that, so you can have multiple AIs to make multiple decisions. That's something that you can do to answer when you've got more complicated tasks. But that does also increase the amount of overhead in managing all those systems. So even that isn't a simple answer. You can't just say, okay, I'm just going to throw more algorithms at it, and that will fix it. Each one of those algorithms needs to be trained manually and needs to be maintained manually. What it can't do, and these are things that I've picked on because I hear people claiming that it can do this all the time. It can't generalize. Like I said, it can only answer very distinct questions that have very distinct answers to. There's people argue that in the next, well, I think 20 to 30 years, we're going to have AGI, which is artificial general intelligence, and it's claimed to be the equivalent to human level intelligence. There is nothing in the field that actually suggests that's going to be achieved, or that it can be achieved in any time frame. I'm not going to say that I'm not going to say that something's impossible, but any AI practitioner will tell you that that AGI doesn't exist, and it's whether it ever will exist is doubtful. Certainly, I would be more. The data suggests that it's more likely to not exist than to not ever exist than to exist. The reality is that the human brain is just far more complicated than we can even imagine. So to be able to achieve that type of intelligence is not something that's even within the scope of science today. So it can't. So because of that, it doesn't have common sense, and it can't do complex reasoning. Conversational AI, I mentioned conversational AI earlier, and there's been a lot of progress in this area. So there's a system called GPT-3, which you might have heard of, which it's a chatbot engine. It was developed by OpenAI in San Francisco, and it can have a really lifelike conversation with you. The thing is, actually, though, it doesn't understand anything. All it knows to do is how to construct a sentence that kind of makes sense to whatever you asked. But that sentence is based on no factual information. So, for instance, you can ask it who won the World Cup in. When's the next World Cup? Is it 2024? So if you ask the GPT-3, who won the World Cup in 2024, it will give you an answer. It will answer you a particular country, which is obviously impossible. That information doesn't even exist yet. So it doesn't have any intelligence behind what it's saying. It just knows, like, okay, if I put these, here's how to construct a sentence, put some information in there. It's just random information. So what else? Learning continuously and adapting on the fly. This is something that people are like, I completely understand why people think that this is real. So people think that once they deploy an AI, it's going to start learning automatically themselves. That never happens. There is one area of AI that can do that. It's called reinforcement learning. It's the system that Arthur Samuel used back in 1959 that I mentioned earlier to build the drafts, the checkers player. But it has so few applications in industry that it's probably not going to be what you're using. And if you're dealing with a company that's claiming that their system does that, then they're probably not using reinforcement learning either. What you can do is you can spend a lot of time in building a feedback loop. But the issue there is that for the data that you're feeding back into the AI, and you need to do, and this requires still a lot of manual interference, because the data that you're getting, that the AI is gathering, or is gathering as it's operating, it's not annotated, it doesn't have labels. The AI doesn't actually know. It knows what it predicted, but if what it predicted was actually wrong, then when you feed that back in, you're just confirming its own biases. You're telling it, you're right in this prediction, in this wrong prediction. So you need a human interference there to provide that correction. And finally, behaviors change, patterns change. So you need to also provide that human interference to also monitor how is the pattern of the data changing, because that happens all the time, especially when you're dealing with humans or weather. So how is that pattern changing, and is the AI learning in a way that's achieving adequate level of accuracy with those new patterns, not the patterns that existed historically when you first deployed it, but with what's actually happening today. So what else AI can't do is that it can't understand cause and effect. It can't tell you why it made those decisions that it made. And this actually restricts its application in many areas where you need explainability. So in current GDPR guidelines, financial institutes don't explainability on whether or not to give credit to a customer is not strictly required, but there's so many other restrictions on the feedback that you need to give that essentially it becomes easier just to make sure that you have an explainable system. So while explainability isn't strictly required in that industry, it all of the other restrictions that surround it kind of make it necessary. And it also can't reason ethically. So we've seen that with numerous things where AI has discriminated against minority groups. So I realized I was meant to take a break earlier, so I'm just going to take a 5-minute break now, because I'm sure you're all kind of getting a bit tired of listening to me, and let people get a cup of coffee, and we meet back at 20 past. And okay. Hi everyone. Okay, now people got a chance to stretch their legs. I'll kick off again. I'm going to. So the next area that I want to talk about is basically facing the AI Summit. It's dealing with how to overcome the barriers that you encounter when you're trying to adopt an AI strategy. Some of the stuff here I'm going to skip over. And I just want to focus on some of the main areas because we are limited in time today. So can you see my screen okay now?
Yeah, we can see it fine.
Yeah, and just can you see what you're seeing is it just one slide?
Yeah, we see the slide facing the AI Summit.
Yeah,
Tackling
okay.
the barriers. Yeah.
Right. Okay. Because yeah, no, I've got two screens, and so the other one then is you know, the other PowerPoint screen that shows you the future slide and that and the controls. Okay. So the four reasons so that people that companies struggle to adopt the technology is there's essentially four main obstacles. First of all, there's generally an issue with inertia and change management, and then there's the common ones that are a bit, or the obvious ones, which are understanding where the value really is for your business, and then understanding the cost. And it's rarely just the direct investment, but also the cost of the disruption and how much time it's going to take. And then there's always a risk associated with what happens when things go wrong. So when we're working with organizations, we use this basically T-shaped evaluation model where we look at the value. So we look at what their problems are across like the entire organization and what value solving those problems actually delivers for each what value the company can get from solving every one of those pain points. And then and then after that, we do when we see what the main areas are, we can then do a deep dive into well, okay, how much is it going to cost to do that, and more importantly, like how much is it going to cost us in resources, and how is it going to disrupt our typical operations, and then the risks. Where's the liabilities? So if you're new to if this is your first time adopting AI technology, you don't want to jump in and do something really difficult and risky that's going to open you up to liabilities if you're not sure how that system can be biased towards underrepresented groups in your data set. That could cause a lot of headaches and trouble that's just going to eat you alive as an organization. So you want to avoid taking on too much risks in the early days. Those things can be done at a later point when you're more familiar with the technology and you're more comfortable with dealing with these types of risks. Most of these risks have ways of mitigating them, but you don't want to be fighting those fires when you're learning how to adopt this in the first place. So in terms of business value, and this is a definition that came from the Innovation Value Institute in Maynooth. So there's 5 types of business value that you can get from a new piece of technology, or like such as AI. So you can increase your revenue. You can make your system more efficient with better use of your assets. You can optimize your costs, manage risks. So that would be an example of using your demand forecasting, managing the risk of being out of stock, or the risk of losing a lot of perishable goods that you have in oversupply. and also increasing your agility. So that's an example of using AI to do your data input for you instead of adding a huge amount of overhead on your administration department. So in terms of, so the first thing you need to do before you can actually adapt this is really think, like have a really long think about what your data strategy is. So your data strategy, basically trying to adopt this technology without having a strategy will be effectively like taking a swimmer and dropping them into the middle of the Irish Sea and hoping that they reach land before they drown. So what you need to do there is you need a strategy, an aim that your data science is actually, your data scientist is actually going to work towards, rather than, so the difference between good data and bad data is essentially, now I could do an entire week of workshops on good data and bad data, but the most important point is that bad data is data that was just gathered because it could be, and then you throw a data scientist at them and say, hey, go find something useful in this for me, without any real aim or guidance. Good data is data that was collected for a very specific task, with the aim to achieve a particular goal. So for that reason, your data strategy needs to be integrated into your overall company strategy. Your data strategy should be helping you solve or achieve one of the goals in your data strategy. So it does that by you take an action, then you gather data on that action. You turn that data into, so that data is raw data coming from an event that happened in your business, whether that's customer transactions or how a machine is operating or usage, some type of event that happened in the domain of your business. You turn that data into actually like understandable information, and you feed that information into some type of analytical system. This is typically where your AI comes in, and that generates insight. Yeah, I realize I'm not using a pointer here. It would be easier if I had a pointer. That delivers insight as to what's happened, as to the trends that's happening in your business. That insight can then be used to make a particular decision as to what action to take next, and your cycle continues. So essentially, your data strategy is really about improving your ability to make a particular decision, and that decision should be something that is going to help you achieve your goals as a company. So if that's a little bit too abstract, I've prepared an example. This is a company called ODG, which was short for Optimal Decisions Group. It was an Australian company that was founded back in 2007 that worked on price discrimination for insurance companies. And we could do a huge discussion on the ethics of that. It's currently there's legislation going through the Dáil that's attempting to block price discrimination, but some critics are saying that is too vague to be effective. But this company was sold on by, I think it was bought by a Norwegian company, I'm not sure. But essentially, if we look at what their data strategy was, or what the data strategy of a company that hires them is basically their company strategy is that they want to make their insurance policies more profitable. Rather than selling just more of the same insurance policies, they want to make the insurance policies that they have more profitable. So to develop their data strategy, we essentially have to work backwards and reverse engineer it. So the action that they want to take to achieve that is they want to sell more profitable insurance policies than what they have been selling. The decision that they need to make in order to do that is basically how do you price insurance policies to basically make them to get more money out of your customers. So what price do you apply to this policy for this particular customer segment? So if you're all probably aware that two people rarely get the same price from the same insurance companies. So the insight that they needed to make, that they needed to in order to make that decision was what are customers willing to pay for their insurance for their insurance policies, and that tells us the information that we need to get on our customers. So in order to get that insight, we need then to basically figure out what levers and pulleys do we need to be able to pull to figure out what customers are willing to pay, and that tells us what type of data to gather, which is basically we need to experiment with our customers when they ring, or with our prospective customers when they ring us up looking for an insurance policy and our price. We need to experiment with them to see at what point they're going to, like, what prices will they agree to and what prices will they say no to, and then be able to capture that information in a way that attributes that to the customer segment that person is part of. And that then brings us back up to the action of how do we sell more profitable in insurance policies. So the interesting thing about this was very few insurance companies would adopt this in the early days, and the first companies that did, when they did implement it, they lost money for the first 6 months of implementing it, because what they were doing was they were just offering random prices to their customers to see, and recording when customers were saying yes to prices and when they were saying no to prices, and they'd done that for 6 months. And then, so they were able to gather that data. From that data, then they were able to turn that into understandable information, which then gave them insight into like what each customer segment was willing to pay. And that allowed them to make the decisions that, okay, how should we price these policies for each of these customer segments to improve our profitability. And then that led them to their desired action of selling more profitable insurance policies. Any questions there? I kind of threw a lot at you there.
That looks good. Good, interesting stuff.
Okay, this concept was originally developed by a group in the early 90s, and trying to remember the original. It was in banking and offering credit cards, and it was, the original bank was I can't remember the name of the original bank, but they set aside their credit card department to basically take this approach. And for the first couple of years, they lost money, and a lot of money. But the parent bank, and it was a small bank, because no large bank would actually attempt it. But it was a small bank that wanted to make a big statement. So after a few years, then things started to change, and their system matured. They were able to, and they started generating more profit. They ended up generating so much more profit that it dwarfed the original bank and was spun out as a separate company. And you probably have heard of them. It's they're called Capital One. But that was one of the very first applications of this type of approach. So then, just to kind of give you an overview of what does, like, this whole system look like in operation. So you're getting data from somewhere. That data could be from edge devices. So that might be coming from user devices like phones or tablets, or it might be coming from IoT sensors or cameras. Or you're getting transactional data that could be from if you've got a physical building. You might be that might be the paperwork that's coming in from each one of those transactions, or it might, if you're dealing with an online system, it'll be like your click-through rates, what people do when they're on your site, things like that. And then other sources could be like third-party data. It's surprisingly easy to get third-party data. Social media platforms are the perfect example of it. Despite GDPR, it is still very, very easy to access to buy data off Facebook about how users basically helping you to profile users. And Facebook don't hide that. It is their business model. It's not a conspiracy. It's or they sell you services that use that data either as a business. So that data is fed into an AI that then makes a prediction. So that might be on a device, or it might be sent to a device. It could be sent to a staff member, it could be sent to users device, or it could be sent to some type of automated process. And then that is then, in terms of infrastructure, you're then storing that decision somewhere in the cloud, along with the data that you use to make that the original input data. And also the AI it might be a third level or third party API that you're using, or it's something that's likely. Most AI systems are actually hosted on cloud servers that give you an access point to send your data and give you another access point to get back the answer. And while it does that, you can also integrate your data storage as well, so that all that data is being stored for you. So, any questions?
So in terms of like the range of, businesses that this would be useful for, are you thinking, like you mentioned insurance, and
Yes.
what sort of other ranges of businesses would you be thinking about?
So I picked on insurance because they're an easy one to pick on, because everyone hates insurance, and even people who work in insurance hate insurance. But in terms of like the type of businesses, essentially, if you have access to data that you may not even be gathering, and that data can improve your ability to make a decision that helps your business, that's relevant to you. So in terms of, I'm going to skip over the next few slides, and I'll send these around afterwards, so you'll have them as reference points later. So this is just some information on the types of costs and risks that probably don't want to get caught up in talking too much about today, and just how we as an organization use these to evaluate. And I'm going to here's an example here's a hypothetical company that we came up with called MedTech. It's meant to be a medical device manufacturer, so a million miles away from your insurance companies. And I'll talk about two other case studies as well after this. Looking at MedTech's pain points. So overall, as a company, they had issues with customer retention, and that was affecting their ARR. But we were actually, but the hypothetical situation is only looking at one manufacturing site. So while there's a solution to that, that particular manufacturing site wasn't really concerned about it. Then detecting faults so because they're a manufacturing site, then they have a quality control process. So detecting faults in that process on their production line can be very manual and very time consuming. So you can create an automated system for detecting those faults, where you have cameras instead of operators looking at your device, or there mightn't be cameras, but you might be doing some other type of stress test on them, or this has been done for microscopic images. It's been done for X-ray images, where you're using some type of testing approach to test is this piece at a good enough quality to be shipped out. And just typically to do that in every couple of thousand pieces. Other problems that they were having was, well, I've mentioned before, automating your paperwork and your data input. Everyone hates that. Having machine breakdowns, I talked about that earlier, where on an assembly line, a machine going down for an hour can cost you 250,000 euros worth of loss of production. Maintaining appropriate supplies, and that's where using demand forecasting comes in. So that's useful for, like, especially in medtech that is dealing with perishable products. So like certain types of bandages or sensors can be perishable. You don't want to have a situation where you have an overstock of perishable goods that you're going to end up having to dump, or even if they're not perishable. If you have excess of one product, there is a holding cost associated with that product. So that's another type of application that you can use this for. And one actually interesting example that I came across recently was a company. Sorry, I just see something in the chat. Okay, that's fine. Someone just had to drop off. A company called, I think it was Evans Distribution in the US. They're the sole online distributor for Girl Scout cookies. So they had an issue that Girl Scout cookies are a seasonal. They're high demand, but it's only seasonal. So to deal with their with the distribution of it, they would hire seasonal staff to come in for 3 months, fulfill the orders, and ship them out. The problem with those staff was that because they knew they were going to lose their jobs in 3 months, they didn't really pay a lot of attention to what they were doing. And that's not true for all of them, but certainly there was too much. There was a large element of it to make it to cause problems for the company. So what they would do then was, instead of following the order that they got, they would just grab whatever flavors of cookies boxes that were handy and just put them into the box and ship that out to the Girl Scout club. And then the Girl Scout club would get it and say, hang on a second, this isn't what we ordered. Then the distributor would have to say, right, I'm sorry, we're going to send you out the correct order. And because it wasn't economically viable for them to retrieve the original order, they would comp that to the club, and they would have a huge loss of product that way. So I'm just seeing some that's coming in the chat. Okay, that's fine. So because of that, what they actually done was they built a system with 2 cameras that would monitor. Basically, one camera was reading what flavors were in the box. Another camera was reading the reference number on the box, and it would cross-check that against the original order and say yes, this is right, or no, this was wrong. Take it off the line and fix it. So there are other types of applications that aren't just churn and insurance-based pricing. So I know we're kind of tight on time now. So when we do this evaluation then for the for medtech, we find that they've got 3 main areas of 3 main projects that they can look at, that they can get value from. One is fault detection, automating. So that's the highest ranking one that we found. Automating basically some of their quality control process. An interesting thing about that is that AI doesn't suffer from fatigue like humans does, so it can achieve much better accuracy at it, and can also be deployed at larger scale, so you can have more checking points along your production line. If you've got a complicated production process that involves several components, identifying faults early on can save you thousands of euros worth per batch, because it means that you can intervene and take off those faulty components early on, and they don't go through the rest of the production process. Automating data input and predicting when a machine is going to break down. I discussed that one earlier. So then before we go, I will talk about some case studies. So I mentioned the case study on the Brexit customs form and digitizing that. So that's essentially helping to automate some of the paperwork on that. And then, interestingly, we got a 99.8% accuracy on when we were doing that, and the only reason for that was because some of the data had extra white spaces that the AI didn't read correctly. In comparison, human level accuracy at its best when doing this task only achieves 96%, but that also suffers from fatigue the longer the human is working on it. And then, then the last case study I'll mention is drug discovery. What I mentioned before about entity embeddings that was created for demand forecasting. Essentially, it's a technique that finds patterns in data sets that aren't obvious to humans. So what happens here is in drug discovery, for example, if there are more molecule combinations that could possibly exist than there are atoms in the entire universe. So it's the search space for solutions is impossibly large, and trying to figure out what new type of drug combinations or molecule combinations that can have a positive effect on patients is becoming incredibly difficult for humans. So these entity embeddings have been used to find patterns around how molecules will interact with each other that humans won't, that any scientist won't be able to figure out themselves, and then suggest, hey, try this combination. And that can reduce can mean that now you're actually, when you're testing different combinations, you're testing targeted ones that you believe already have the ability to achieve what you want to achieve and not have too many side effects. So this type of approach is going to be essential for basically curbing Eroom's law. So If you're familiar with drug discovery and pharmaceutical science, then I don't need to explain this, but for anyone who's on the call who isn't, Eroom's law, it's Moore's law reversed for drug discovery, and it means that basically as time is going on, it's getting more and more difficult to find new drugs, and the cost of commercializing them is getting exponentially more difficult. So currently it costs between $2 and $2.5 billion just to get one drug to the marketplace. But that includes all of the wrong avenues that you went down in trying to develop that new product. So by reducing those wrong avenues, you can really start to curb the effect of Eroom's law. So I realize it's nearly 12, so I will wrap up there and open up to questions. Anyone have any questions?
So it sounds like AI is practically applied quite simply. When you mentioned those cameras, I think we always think of something very sophisticated, but it's not necessarily the case. I think you probably can apply some smarts and technology in more simplistic ways to be more efficient in small and large companies. Of course, back to the data argument, you do need more and more data, but you can generate data. And I think one of the things if you are considering AI and use of your data, you do need to think about, it being good and clean, and that, it is usable rather than the gathering for sake of it, as you mentioned earlier. So I think, when you're looking at it now, probably it's an initiative internally in the company to have someone dedicated to ensuring that there's a good collection of data rather than a random collection of data, so that you're doing it right from the very beginning. But like everything else, it's starting it, piloting it, testing it, and then honing that.
Yeah, so there's a new trend that's kind of starting to happen of a new position that's existing within companies called the digitalization officer. So it seems to really only be in the early days of people discussing it, but I think it's going to be something that's going to be more necessary as companies grow and this technology emerges more and more. One of the things that we're trying to do as an organization is basically find those obvious, simple applications, and such as like checking what orders are going into what boxes, or like automating paperwork and that, and making that easier to understand for people. So Yvonne is asking the name of the website. Yeah, so it's Kaggle, spelled K. I'll just put it in the chat to everyone. It's Kaggal or EL. I can't remember if it's AL or EL. So,
Iain, can I ask you a question?
I think it's EL. Yes.
So what I took from that is that AI is the starting point rather than the be all and end all. So we collect our data via AI, and then we decide what we're going to do with the data, because AI can't make that decision for us. But the final part of the puzzle, which should probably be step 5 in the diagram that you showed, is how do we apply the data, and that we should start with the end in mind. Would that be correct?
Yes. Yeah. That's basically how any good data strategy is applied, is that you're applying AI to achieve a particular goal that you already defined yourselves, rather than letting artificial intelligence tell you which way to go. Anybody that you hear, so one organization that you will hear talk like that is OpenAI in San Francisco, and they are notoriously use that type of language because it creates good media publicity for them, and they get slated every time by the rest of the AI community and practitioners that what they're saying doesn't match up, and time and time again, we've seen that their claims on direct AI technology and what it can do, and doesn't actually match up to what the truth is, because they've become very good at, I guess, what's the right way of doing it, but of saying it, but they're very good at communicating things that they know is going to get a lot of traction from the public.
Okay, thanks.
So you can take that any way you want. Any other questions? So something here in the chat. Which AI algorithm do you think will have an impact in the future? The way deep learning did over the past few years. I don't think we're finished with deep learning by a long shot. I think there's still a lot more growth in deep learning. So what I mean by that is, I think there's there's going to be a lot of new application specific or task specific architectures coming out in the deep learning field. That's going to help industries move forward. I realize I'm saying this, I really hate making predictions on the future. But yeah, I think that's going to be something. So, and we've seen that with the likes of transformers over the last few years. So transformers are things that they're used for language models, for making conversational AI. So if you understand the terminology around it, transformers were heavily influenced by design of vision-based systems, which are convolutional neural networks. And I think convolutional neural networks have a lot more to give than we give them credit for. Then, aside from deep learning, there's been a lot of algorithms that have been working very well for the last 20 years, but because they're not operating that haven't typically been operating in fields where that get a lot of sunlight from the press or from media or people, or grab people's interest. But I suspect there will probably be some shift there. So any optimization approach has been delivering value for like well over 20 years now. So that's something that, and it's likely to, the need for that is likely to increase. In fact, there's been these optimization approaches have been used essentially to minimize effects or maximize effects. So it could be minimizing your packaging or maximizing how many products you can ship in one shipment. It can be optimizing your electricity usage or things like that. But it's actually also been used to develop classifiers like deep learning, and in some cases it's outperformed deep learning, but it's even more computationally expensive to do. One thing that I heard that sounded really interesting, if you understand the terminology, was using reinforcement learning, so the ability for a machine to teach itself within recommender systems. So recommender systems are products that are basically teaching you, or are recommending new things for you to do based on your profile and what similar profiles have liked. So Netflix has like some of the best recommender systems. Amazon has effective ones, but they don't actually work very well. Any other questions? Okay, something's coming here.
Yvonne asking about funding. So again, to actually do some of the analysis and look and forecast. So it's difficult for a smaller company to, say, I'll do that myself, or even some of the SMEs, to be honest. So you need someone with a bit of the in-between sort of expertise. Is there funding there? You know, again, it probably comes back to, you know, the local enterprise office feasibility funding for something like this, I would say, predominantly for early stage companies. I think then, you know, there's always innovation vouchers, may or may not be available to some people, but there's innovation partnerships, which would be larger. And, you know, there's a lot of cross-border funding at the minute. In terms of European funding, I think that's probably for larger projects. So I would see that something like this is probably a shorter analysis. So I would be pointing towards EI or LEO funding in your own region. But the, you know, the outcomes here have to be heading towards maybe for those a product that's maybe exportable or advances, you know, the actual, I suppose, looking or analysis will have to advance your product or your offering. But you obviously would be, you'd be learning from it.
Okay, and there's a question from Garrett there. Will blockchain technology help advance machine learning? I'm willing to eat my words on this, but I would say no, I don't believe so. The applications of blockchain. So there's some uses now around NFTs and that, that I think could be useful for some applications, that like gaming, that, but I don't see any use of it in machine learning right now. I'm willing to eat my words on that in 5 years' time.
It's an interesting one. That one's really kind of bedded down now, actually. The blockchain side of things, probably a little bit more advanced than AI, I would imagine, at this stage, where it's been brought into companies, large and small, mostly large companies who've, you know, got maybe financial or supply chain applications for blockchain. And it's not the hype Bitcoin, Ethereum side of the fence that's really being used, or blockchain's being used for. It is there. They're doing well, actually. So it's a bit of a change in that over the last number of years as well. But AI is kind of separate on this one, I think. They're assessed separately anyway by the big companies.
Okay. Any other questions? So if my contact details are there, I'll also share the slides with you. But if you have any questions afterwards, you're feel free to reach out to me. I'm going to stop sharing. I think, Angela, you want to share some stuff.
Fine. Thank you very much, Iain, for your time. Thanks everybody
for having
for joining. It's really a broad overview, and it was a tough ask. You're not from the healthcare sector necessarily, and looking at this and providing examples that people could relate to is really important. It's fairly tenuous, you know. I think from our perspective, it's hard to get under the skin. So it's a great introduction with some practical examples there. But yeah, I mean, we think that there's probably this area is heating up, and you know, there's probably scope to roll out some more information and education around AI as well. So much obliged, Iain. Thanks very, very much.
Yeah.
I'll just share the screen with the next session from our side. Is, you know, building apps for healthcare, and again, that's something we see that people are doing. So we do have Larry Breen, who's from Nearform, and Nearform are the company, the Irish company behind the COVID app. So they've been the one that's sitting on your phone for the last you know, year and a half or more, and I use daily. I don't know if others do, but I think it's important. So we have Larry in to talk about, you know, the experience of that, but a little bit broader in terms of, you know, the challenges and the how-tos to build something of that nature. And I guess it will touch on the data piece, so a little bit of a follow-on in terms of what we spoke to today. And then Thomas Coleman's the CEO of Zendra Health, and Thomas and his co-founder, I know from, you know, kind of working with them as they built out the company, and they met with many challenges in trying to build and provide apps in the healthcare setting. So I think he will speak to a lot of the watchouts as you maybe are considering doing the same. So both of them being able to practically talk about their experience. And again, we'll do workshop format and happy for people to engage. So they'll do a little bit of a chat in the beginning to tell a bit about their experience and background, and then it'll be open. So that's me, and thank you. You're more than welcome, any of you, to contact us at any stage, and further questions. And if you want to connect with Iain directly or through us, feel free. Thanks very, very much, everyone. We'll leave it there. All the best.
All right, thanks. Bye.
Thanks very much, Iain.
Thank you.